Some causes of cancer are having too much sp2 proteins, which turns stem cells into cancer cells. Having cancer in your genetics, and you can have immune system problems. Lack of co-stimulated molecules can destroy the way the natural killer cell's abilities. DNA can get mutated and affect the way a cell divides. Because of this, cells become a tumor instead of dying. White blood cells determine whether or not to kill human cells. If a cell is turning into a tumor, then molecules are put on the outside to get rid of cancer cells. Cancer cells use the enzyme telomerase to extend its lifespan. This is why they accumulate to make tumors. There are many ways to treat cancer. None of them are cures, but they still help. Some of the treatments used today are radiation, chemotherapy, hormone therapy, immunotherapy, and some combination of surgery. The search for a foolproof cure for cancer still continues today.
Take one.
Is it hard for you to say those words? We're trying to cure cancer.
That's a really good question, and why it's hard to say we want to cure cancer. We do. And I think sometimes it's hard actually to think that you might actually succeed.
Patients that we're treating on this clinical trial have absolutely no other options left for them. These are patients who are unfortunately destined to die of their disease, and in a fairly short amount of time.
Emily Whitehead, 554.
So Emma is incredibly matter-of-fact about all of this stuff. This was a child who had had her leukemia come back twice. The parents were looking for a miracle.
What we've learned how to do is train the immune system to recognize and then kill tumor cells.
It's a procedure where we collect their T cells, and they are infected with a virus that will genetically change them so that they will now see and react against their leukemia cells.
And we actually use the HIV virus to do that.
So you're taking the HIV virus and infecting healthy cells with it to help kill cancer?
Yes. The virus has been engineered so that it can't cause disease anymore. But it still retains the ability to reprogram the immune system so that it will now attack cancer cells. We call those modified immune cells serial killer cells. Each infused cell can kill more than 1,000 different tumor cells.
But the reality is the dramatic responses of cancer to new treatments are very unusual. We need to make it clear when we talk to a family that it may not work. Emma was given her T-cell treatment, and within a few days, she was very sick. She had breathing difficulties, she had blood pressure difficulties. We knew that she could not have gotten any sicker without actually dying.
But then a remarkable thing happened. The T cells were growing, they were starting to fight the cancer.
Within hours, Emma's fever disappeared.
It was like the calm after the storm. The clouds went away, and she woke up and there was no leukemia. When that child survived, it was, of course, an amazing event.